The mission of the Laboratory for Atmospheric and Space Physics began as studying from space the Earth's atmosphere, near-Earth space, and the Sun. Over time, our mission has evolved to be studying the planets in our solar system. And more recently, we've extended that mission to studying planets around other stars, what are called exoplanets. Our goal is to have small satellites, and the CUTE satellite is geared toward understanding more astrophysical objects.
CUTE is the Colorado Ultraviolet Transit Experiment. It's also actually small and cute, and it really had two purposes. One, to see if we could actually use a small spacecraft to do really fundamental science. And then a second, we wanted to understand more about the atmospheres of these hot Jupiters.
CUTE is one of the first CubeSats that has used a telescope, so a glass-mirrored system to magnify and focus light from stars. And unlike most satellites, CUTE was very constrained to a certain form factor, a CubeSat. And so we actually developed a telescope that was shaped the same way as the satellite to use as much area as possible. We didn't have the freedom to build the typical telescope, which would be a tube, a cylinder, with round mirrors. And I mean, it sounds like a very simple innovation, but it was something that really hadn't been done before in a spacecraft system like this.
CUTE has a couple of innovations. In addition to being NASA's first exoplanet CubeSat, the first dedicated mission to go out and take spectra of these extrasolar planets, it uses a unique telescope design where it's got this strange rectangular telescope where it allows us to collect about 3 times as many photons from the parent star as we would with what you might think of as a traditional round telescope. So we put these two pieces together to, try to do something fundamentally new in a new package.
When we really got in the thick of it, it was really, really hectic. There was a lot going on. So CUTE has a telescope, it has a diffraction grating, it has a detector, it has a focusing optic, it has a slit that blocks out some stars in the field but lets us look at our own star that we're interested in, our target star. So there were a lot of individual components that needed to be tested and measured individually first before we integrated it all and tested it on a large scale. So there were some days where it was hectic. There was a lot going on. If a test that wasn't set up correctly, we would have to design and machine a part to make it work. It was also very fun working with a smallish team of people, including myself and undergraduates and a couple of postdocs, working really closely together to figure out what we needed to do and then doing it. It was hectic, it was fast-paced, and it was really creative.
We have about 30 undergraduates that are actually operating NASA and other agency spacecraft. It's a very powerful thing when an undergraduate student can say that I'm sending commands and getting data back from a $700 or $800 million NASA spacecraft.
The educational aspect of LASP here at large is, LASP is tied in every single division, hires undergraduate and graduate students, PhD students, postdocs, etc. So especially on the small sats, they're such small programs that a lot of our undergraduate and graduate students actually get to kind of dip their toes in all different disciplines.
I have to say it has prepared me a great deal. What I'm doing right now, I could not have done it if it was not for the classes that I've taken.
CUTE has done its mission. We had some challenges. We had to learn a lot when it got into orbit. We had to learn exactly how it was responding to our controls and exactly how it was behaving as an instrument. But for the most part, when we got our first transit curve and we saw evidence of an exoplanet passing in front of its star and an evidence of the signal that we were looking for, that had taken several months in space, and it was just an experience where we said, we did it.
It was really exciting. It was, we had taken images with the spacecraft, and we had downlinked them, and we knew that the instrument itself was working, but to observe a transit, you have to take an image of the same star over several hours. And so it took time for us to actually wait for CUTE to observe over those several hours of time and then get the data down and then process it and then try to look for the signal there. But once we saw the signal, it was like a sigh of relief. It was, oh, thank goodness it's working. It was, my gosh, finally, I'm just glad that we finally got to that point. And it was also wow, we have data that nobody else has seen before. It was a lot of different emotions.
We believe that the kind of education and training that we do is a much more profound educational experience than could ever be obtained in the classroom alone. So we're delighted to work in cooperation with departments that are offering classroom education, but we also believe that our hands-on training is among the most powerful and maybe in some ways the most unique aspect of education here at the university.